afternoon, everyone. My name is Finnick Milwaukee. This is Marine Beautifully, Michael Horn, and Cameron Piotek. We researched how the United States is going to adapt and change after China's national sword policy, when the United States is already unprepared to deal with all its textile waste. First of all, for decades, China has been taking a large percentage of the world's waste. According to Amy Alberts, Shinli Wang, and Jenna R. Junbeck, in 2016 alone, about half of the plastic waste intended for recycling, 14.1 million metric tons, was exported by 123 countries, with China taking most of it, 7.3 million metric tons. Reporting in 1992, China has imported 106 million metric tons of plastic waste, making 45.1% of all cumulative imports. Collectively, China and Hong Kong have imported 72.4% of all plastic waste. However, what is China's national sword policy? Well, according to Cheryl Katz of Yale University, China's national sword policy, enacted in January of 2018, banned the import of most plastics and other materials headed for that nation's recycling processors, which had handled nearly half of the world's recyclable waste for the past quarter century. This was due to China's population increasing to a point where China could no longer deal with their own citizens' waste plus other countries' waste. This led to countries struggling to deal with their waste, including the U.S., after China stopped importing most of their waste.
According to Martin C. Heller, Michael H. Mazer, and Gregory A. Keelan, all affiliated with the University of Michigan, in 2017, even before the sword policy was implemented, more than 3/4 of the plastic reaching end of life went to landfill, and less than 8% was recycled. This means that even when China was accepting recycling, most of the United States recycling was still ending up in a landfill or in large compressed rectangles of recycled material in the back of a warehouse, and that solutions at the time were not working properly. According to National Geographic, China accounts for about 1/3 of all clothing exports, and that equates to tens of billions of individual garments. It accounted for 37% of U.S. textile imports in 2017, according to the United States Trade Commission. And according to the University of Tennessee Technological University, in North America alone, every consumer throws out an average of 81 pounds of textiles every year, which totals more than 26 billion pounds of textiles in landfill. While laying in landfills, textiles generate greenhouse methane gas and lead to toxic chemicals and dyes into the groundwater and soil. Next slide, please.
Our first solution to this problem is the circular economy. According to the Network for Business Sustainability, the circular economy keeps resources such as products, materials, and energy in the economic system for as long as possible and at the highest value possible. Products gain value as they're manufactured through the input of materials, labor, and energy. Essentially, the circular economy is when a resource is either reused, remanufactured, or recycled. Basically, this economic model does everything in its power to stop resources from being wasted. Next slide, please. In a normal economic model, items are manufactured, used, and then eventually wasted. The production of goods in a linear economy is at the expense of the productivity of our ecosystems. This model proves to be inefficient in terms of protecting the environment and reusing materials. In comparison, a circular economy would outshine a regular economy on every level. The ecological disadvantage of the linear economy is that the production of goods at the expense of the productivity of our ecosystem. In a circular economy, by reusing materials as much as possible, environmental impact will be kept to a minimum. Next slide, please. While a circular economy is clearly the better solution to a linear economy, it can be incredibly difficult to implement. According to Patricia Van Leeuwen and Luc and Van Wassenhoven, many challenges accrued in the transition process, including finding the right market for the recirculated product / service, such as textiles, setting up the reverse supply chain, selecting the right partners, and making sure the new business model is sustainable in the short, medium, and long term. While the implementation process with the solution is difficult and complicated and takes lots of time and preparation, the payoff is worth it. According to the Ellen MacArthur Foundation, substantial net material cost savings are based on detailed product level modeling. The report estimates that the circular economy represents an annual material cost saving opportunity of USD 340 to 380 billion, and at the EU level for a transition scenario with USD 520 to 630 billion, or a recurring 3 to 3.9% of the 2010 EU GDP for an advanced scenario. And all the net materials used in the reverse cycle process. Essentially, the potential savings and reduction of environmental impact after the implementation of circular economy greatly outweigh the potential cost and time required to introduce successfully. Next slide, please.
The second solution, acid hydrolysis. According to James Spite, doctor and environmental consultant Acid hydrolysis is a hydrolysis process in which a protic acid is used to catalyze the cleavage of a chemical bond via a nucleophilic substitution reaction with the addition of the elements of water. This process converts cellulose and starch into glucose. Moreover, this product, glucose, can then be used to power vehicles and transportation. According to Asam Junapur and others, this huge amount of fiber is processed into apparel, home textiles, and industrial products, and after a certain amount of time, end up in waste streams. This amount of cellulose has the potential of production of approximately 20 billion liters of ethanol. Next slide, please. According to Miguel Sanchez, a chemical engineer for Lund University in Switzerland, two-step acid hydrolysis experiments consisted of a dissolution step in which waste textiles were dissolved into a concentrated sulfuric acid solution, followed by a glucose production step, in which a diluted sulfuric acid was used to completely depolymerize the cotton and form glucose. The glucose, like the biomass of other plants, can then be used as fuel for transportation, according to Oregon State University. Next slide, please. Lastly, according to Hans E. Gridlin, chemical engineer at the University of California, Berkeley, the cost of making glucose is in the range of 1.7 to 2.45 cents per pound, depending on the slurry concentration fed to the reactor for the acid hydrolysis. The range of the cost of glucose is fairly cheap and feasible in order to mass produce glucose from the recycled textiles. However, there is dissent to implementing acid hydrolysis. The International Food Research Journal states that a few drawbacks of implementing acid hydrolysis are a relatively low yield and the high process temperature and formation of undesirable byproducts shifted from the production of the enzymes. Next slide.
Between a circular economy and acid hydrolysis, we decided that a circular economy would be more helpful to implement, as it would have a bigger impact dealing with all types of waste rather than just textiles. First, according to Anders Welcome and Christian Skonberg, the move towards a more circular economy will result in the creation of new jobs in many sectors of the economy. However, acid hydrolysis will only be able to take place when workers have been specifically trained to operate it. Second, acid hydrolysis is severely limited in what it can turn into glucose, meaning only organic materials, while a circular economy trades and uses all materials, as there is always an industry that can use another's waste products. In fact, circular economy is described by Fenna Brunsma and Jolene Brennan as an emergent framing around waste and resource management that aims to offer an alternative to prevalent linear take, make, dispose practices by promoting the notion of waste and resource cycling. Strategies such as, but not limited to, reuse, recycling, and remanufacturing operationalize this concept. Third, a circular economy could save the United States hundreds of billions of dollars. In fact, as said earlier, according to the Ellen MacArthur Foundation, substantial net cost savings. And the report estimates that a circular economy could save up to 340 to 380 billion United States dollars. This all concludes that overall, due to its bigger impact, wideness of materials constantly being reused by other industries, a total net material cost savings, implementing a circular economy would be a better solution in continuing to solve the United States waste problem. Thank you, and have a nice day.